Hi, I'm Andy Brittain, and I've been teaching physics in UK secondary schools since the last century. I have a very deep passion for communication between educational institutions and strongly believe that outreach and enrichment projects can really bring science to life for students. Once that passion is ignited, there's no limit to what they can achieve. Window to the Stars was developed to complement the twin single binary stellar evolution code used by professional astrophysicists. The software acts like a web browser for stellar evolution modeling. It's a graphical user interface that makes it easy to create stellar models. It provides users with the tools required to interpret these models and help them to understand the physics at work and make predictions about how stars will behave. Several years ago, I met with Rob Izzard, who had developed Window to the Stars at the University of Surrey in the UK. He had seen the potential for this software to enhance the science capital of students at secondary schools, and with that in mind had developed a new outreach program. I seized the opportunity and offered to trial the program with several of my students. A great synthesis of skills was initiated. My experience in the field, so to speak, meant that I was well placed to judge how the program could be optimized for use in schools. Firstly, we had to overcome the school network restrictions, and we did this by switching the software to a small standalone computer, the Raspberry Pi. This removed any interaction that the Window to the Stars software would have with the school system. We also needed to adjust the documentation. I changed a few aspects of the conceptual flow, simplified some of the sections, and provided a little bit more detail and imagery for other sections. I also added review questions that teachers could use to monitor student understanding, and I wrote a brief teacher's guide. We carried out several very successful trials with students at my school, including presenting our work at student conferences and to our local Member of Parliament. However, to progress this wonderful program further, we needed to bring in more schools. I advertised the program via teacher forums and received numerous expressions of interest from across the country. We then set up meetings with the Royal Society and negotiated the wording of a partnership grant that would provide schools with up to £3,000 to fund their own Window to the Stars project in the UK. My school also gave me regular day release to show other schools how to run the program. Over time, the program has gained interest in many areas. The Royal Astronomical Society now promotes the program in their output, as does UC Berkeley in America, and teachers from all over the world are now exploring its potential applications. I've personally had information requests from teachers working everywhere from India to Brazil. The Science and Technology Facilities Council in the UK has also recognised the huge benefits of this programme and provided a research grant to support its development at the University of Surrey. Part 1 of the programme introduces the ideas of stellar astrophysics and computer modelling. Part 2 contains ideas and exercises to help students understand the astrophysics of stars and direct them towards independent project work. When you first run the software, you're given the Options tab. Here we can choose the initial conditions of the star, i.e. its mass and metallicity, and change the physical prescriptions that are used during the modelling. For the schools program, we only examine single stars, although the software is designed for binary systems, so you'll have mass 1 and mass 2, and you can operate them both separately. Once the initial parameters are set, we can select the Evolve tab and start to grow our star. In this window, we are presented with lots of code information for the experts to interpret. It'll be a while before school students would be in a position to use this, although there's nothing wrong with ambition. During the evolution process, students can watch their star's pathway grow across a Hertzsprung-Russell diagram via the HRD tab. The path actually lengthens as the student watches, which I think is a unique feature of this program, watching it actually grow in front of your eyes. And the window expands to accommodate the path of the star as required within the diagram. The student can see the behavior of the star as it progresses from its initial stable state through to its departure from the main sequence and subsequent demise. The colours of the tracks are as close to a representation of the star as possible, but the user has extensive control over the presentation and labelling. It may, for example, be informative to include stellar age labels to understand how rapidly different stages progress as the star ages. The Row T tab shows the density and temperature track of the star. Students can also watch this lengthening as the star evolves, as they could with the HRD graph. The lines beyond which different elements are fueling the star are shown on this graph, and students can observe the changes in the stellar structure as the path crosses these points. For example, when the track crosses the helium burn line, helium fusion starts and the center heats rapidly, while at the same time its density drops. The Structure tab allows you to make graphs of one property of the star versus another over its entire evolution, or even just a portion of its evolution. There are an enormous number of parameter comparisons that can be made. This one plots the radius of the star versus its age. We can see that towards the end of its life, a solar mass star will increase its volume tremendously. Each star is iteratively evolved, with each model corresponding to a particular stellar age. The time step length for each model depends on the extent of parameter variations. It'll be very short if there are lots of variations to account for, and it will cover quite a long period of time if there's barely any change in the stellar structure. You can plot a huge selection of stellar properties at each time step using the Internals tab. In the case shown, the helium abundance by mass fraction is plotted as a function of mass coordinate for every 100th model of a solar model set. At the beginning, model 2, the star is about 27% helium, while by model 1402, the core, from 0 out to 0.47 solar mass, is 98% helium. The Kippenhahn tab makes three-dimensional surface color plots of data. On the XY axis, you can plot any structure variable like time, model number, mass coordinate, while as a color, which represents the Z coordinate, you can choose any internal property of the star you like. Here we show model number on the x-axis, mass coordinate on the y-axis, and the color represents the logarithm of the temperature. So yellow is hot while blue and black are cold. You can see that up to just after model 200, during core hydrogen burning, the star hardly changes. After this, until about model 1200, the core heats while the envelope cools. The star is becoming a red giant. From model 1200, the star has a hot core and a very cool envelope, until just after model 1400, when helium ignites in the core. Window to the Stars allows you to change the format of any of the images you generate, and it even has a layers option through which you can run multiple stars at once to compare their properties. The program documentation covers stellar spectroscopy, timescales in stellar physics, which are dynamical, thermal and nuclear, computer modeling and Python programming, stellar structure and energy flow, astronomical distance measurements, Cepheid variables, fusion processes and star cluster dating. It even provides student research ideas such as exploring the impact of different stellar hydrogen burning rates on the potential for life-bearing planets in orbit around the star, or producing a model of Barnard's star, for example. In short, Window to the Stars is an absolutely marvelous piece of software. The program is extensive and supports the steady development of expertise. It's perfect for use in schools and comes with the support of a network of experts in both astrophysics, courtesy of Rob Izzard, and the school environment, courtesy of myself. If you would like to find out more about the program, either to offer your support or to use the software in your classroom, please visit the website at starsforschools.gitlab.io, or you can email us at starsforschools.wtts@gmail.com. Thank you very much for listening.